did a great job with these. I'm going to post them. Does anybody else have their Steeler extra credit, their Steeler logo? Bring it to me, please. Reminder, you've got till Wednesday to do that. Okay, Wednesday at the start of your, thank you. Wednesday at the start of your exam, it's due. And I told you made two. Oh, that's exciting. Yeah, Richard. On the bottom. At the start of that, that's when it's done. I'd be lying to you if I told you there are a lot of opportunities for extra credit during the year, so you might want to find a time to get it done. It is possible based on the fact that people are doing it. Okay, so good job. Okay, 1.8 is actually the last section of Chapter 1. Okay, your next test is until Wednesday, so you get a couple days to review. Not going to lie, a couple of you looked at the distance formula yesterday like it was kind of foreign, so I want you to pay careful attention to what's going on here today. Please check it. Maybe it looks better on the second take. 1.8 is very different. Okay, and then after that, we'll have a couple days of review next week, and we'll go forward from there. Okay? Okay, so let's go section by section, and you gotta tell me like what parts look good and what parts don't look good. Okay? First set, 1 through 8. How does the midpoint stuff look? Does that look okay? Yay, nay? It's just the average of each of them. So this is your midpoint formula. Add the x's together, cut it in half. Add the y's together, cut it in half. That's your midpoint pretty much all the time. No tricks, no gimmicks. Okay, you do get a calculator on this next exam. Okay, that's why I have you have one today. So you don't really need to be able to manipulate decimals without it. The 1 through 8 I think should have been okay. We went over a lot of options yesterday for finding the other coordinate. Okay, I think before I get to the distance formula, the coordinates of y are given. So y is given, I'll just do one of them. If y is given as 0, 2, the midpoint is the same for all the problems. Where's the midpoint? 3, -5? And then they want the coordinate of point x. Okay, so for this problem, it's over here. If you had a graph, you could simply count it. I gave you two options. I'm fine with either of them. It doesn't matter. Okay, probably the quickest way is to get from 0 to 3 is add 3. So you add 3 more. Okay, to get from 2 to -5 is to drop, what, 7? Okay, so then you do it again. That's the fastest way. But I told you yesterday what you could do is do two baby equations. So that's my x value of one of the points. That's the midpoint. That will also work and get you there. I don't care how you get there. When I give questions like this, you just need to get the proper other endpoint. As a total fail-safe, if you don't understand the moving logic or the formula, could you graph it on a piece of paper? Yes. It's just a question of how much time you want to invest, okay? The distance formula, okay? Now, some of you had like a heck of a time with this yesterday. You're looking at it like it wasn't anything you've ever seen before. What did we say that this basically is? Say it again. It is the Pythagorean theorem. The only difference is, instead of just an A, a B, and a C, okay, this is your A, this is your B, and then this is your C. Okay, so the difference in the x coordinates, bless you, is your A. The difference in the the y coordinates is your B. The square root is because we want to find it, but it actually started out like this. Okay, so hopefully you got a little used to it. I'm not going to do all of them because they do get repetitive, okay, after a while. It does say round to the nearest tenth. I did tell you you'll get a calculator on an exam. Okay, so the rounding is just a good exercise in thinking, but come next Wednesday, you'll have a calculator and you should be fine. Let's just pick out one of them in 12 through 17. I don't know, pick one.
12.
12's lame.
No, 12's good.
Oh, I see why you want 12. Okay, we'll do 12. Psych.
No.
We're catching on. And you know what? Yeah, just for fun, that's the only one we need to toss out. Everything else is safe. I don't feel comfortable with 17 because it's got one of them, and this has one of them, but I can't avoid them forever. I actually want 17, okay? You didn't think I was going to catch that, did you? I didn't either, okay? Let's talk 17, just the one. Because if you can do 17, You can do any of them. Question to the group. Which one is my x1 between these two? It doesn't matter. I get to pick. So I can either do -5 minus -3 or -3 minus -5. It does not matter. But kind of like when you're finding slope, if I'm going to go in this direction, I should probably go in that direction. I get the same answer. Okay? Now from here, it's just calculations. There's no shortcuts here. -5 minus -3, get an answer, and then square it. 5 minus -2, get an answer and square it, then add them together, and then take the square root. There's no shortcuts. And if you try to do stuff like this, I'm going to cry. Damn it, I can't do it. If you try to do shortcuts, I don't know why I wrote the square root in. Why am I going to cry if you do that? Because that's not how square roots work. That is not how square roots work. You cannot do the square root of a squared plus b squared is a plus b. Please don't make me send you back to algebra 1. So there's no shortcuts. So if I picked out just one more, okay, if I picked out 15, okay, because again, they're all repetitive. Not 15. Yeah, 15 is fine. They all get repetitive after a while. 2 minus 10 squared, -6 minus 0 squared. Calculate, square it, calculate, square it, add it, take the square root of the whole thing. Okay? Hopefully it got a little bit better after the homework. Some of you looked at it yesterday like we've never seen it before. It is just the Pythagorean theorem. Okay? Good. I don't know what you noticed about the trapezoid one. Okay, but you should have noticed the trapezoids were congruent to each other, or the diagonals, I should say. So when you found the length of BD and the length of AC, you actually find that the lengths of them are actually congruent. Okay, and then this question was just doing the distance formula, not with 2 points, but actually with 3. Same kind of idea. Okay? So you will need to know the distance formula for next Wednesday. You'll have a chance to practice at it again. Okay? All right, let's go to 1.8. Okay, 1.8. We got a couple of these right here. Got a couple of them. Yeah. Well, I don't need a birthday slide because we got this right here. So, yeah, good times. Festive outdoor party between the three of you. Should be good. Okay, perfect. Can you get 1.8? Just rotate to it a little bit, get calculators. Let's get Sarah, you want to give me those Steelers logos? Okay. Does anybody know what those are? Say it, Cam. The crop circles. Have any seen the crop circles before?
Don't the aliens see those things?
I don't know what the aliens see.
Like, is there like a thing where like this movie where like,
Yeah.
people like see like the songs?
Yeah. Look at that. Okay, good. They're going to create circles. We're going to recall a lot of old knowledge today. Okay, a lot of today is actually a review of stuff you've once done, but we'll kind of see where we land. Okay, so we're going to talk perimeter, circumference, and area. You're going to see a good bit of circles, which is why I show this. Please feel free to send me circles you see in your daily life. Okay, cool. We're going to talk about circles. We're going to talk about how to find the area of irregular shapes like this. Okay, and then things like this. We did a lot of these things in a very brief fashion last year. Okay, we're going to hit them pretty quickly. Okay. So you've got, let's see, 1, 2, 3, just 3 warm-up questions. Go ahead and work through those together. 1, 2, 3. So the aliens.
Wait, Ava, is it? Ava, is it?
Hardest question for me on there was the second one, but I know a lot of you will know it.
I know. Is it?
Lily, what was the next vertex? SKR? Good. Anybody like me, you have no idea the order. Like that's it. That's the extent of my knowledge. I know that, and I know ones in my lifetime. Okay. Okay. So what fills in place? Washington, Adams, Jefferson, Madison. Wasn't he like super short? I think he was the short president. I think he was short. I could be wrong. Okay. All right. Please work on this question. It's actually pretty quick. putting up Addies as the gold standard. All right, come on, come on, come on. You ready to show me some proof for the multiple choice one? Yeah, be ready to show me a little proof. Makes sense. Please be ready to show me a little bit of reasoning on this multiple choice one, because I do want to know where your answers are coming from. Oh, well, enough said.
Thank you.
Give me about another minute to finish up that one question. Yes. Not by me, but by others.
I know. Where am I supposed to? We're gonna have to wait. I know.
Alright. Okay, let's look at number 3. The segments. A lot of you have a choice, but you have no reasoning to back it. Also, some of you do have it wrong. The segments on the coordinate plane represent 2 parallel roads in the neighborhood. That's actually pretty crucial. They tell you they're parallel. Let's pretend they didn't tell me that. Couldn't I just find the slopes and prove they're the same?
Yeah.
Okay, I don't have to because they told me. But if I was suspecting they were parallel, I could find these slopes and they're the same. That's actually pretty important. Okay. Each unit on the plane represents a half mile. By the way, some of you that's already going to affect your answer, but we'll get to that later. A new road will be built connecting the midpoints of them. Okay, and we want to know the length of it. Question: do we actually have to find the midpoint? Why not? Somebody raise your hand and tell me we don't. We don't. Ava.
Because they're parallel, so no matter where you measure from, they're the same distance.
Yeah, let's pretend I thought that was the midpoint, which I'm not going to lie, that's a pretty good guess. Well, isn't that the same distance as that or that? So you don't even need to find the midpoints. I actually went here. I didn't even find those coordinates. Then I went 1, 2, 3, 4. 1, 2, 3, 4, 5. This is my unknown. And then you actually don't even need to do the full-blown distance formula because you can just count it on there. Okay, ooh, my 4 got chopped off. Okay, Pythagorean theorem, 4 squared plus 5 squared is c squared. What's this, 16 and 25? Maybe? So c is the square root of 41, which comes out to about what?
But then it's half.
Oh, but then it's half. So the answer is not c, it's actually b. Did anybody do all the beautiful work and then make it 6.4? You've got to look at that scale. Okay. So, again, here's my problem though. Some of you are really looking at the distance formula like it's this big scary thing. It's just this. Now, on the actual graph, I can just count. But this is my x1 minus x2. If we're listening back there. This is my y1 minus y2. So it's really nothing to freak out about. Okay, the picture definitely helps. Okay, that is your answer. Today's a lot of vocab, but a lot of it's going to be fill in the blank. It's not going to be stuff you don't know, but it's going to be things that you need to recall and get them accurate. A polygon, a closed plane figure formed by 3 or more segments. It is not 3-dimensional. It is a plane figure. Now, just for funsies, there are 1, 2, 3, 4 fill in the blanks beneath it, yeah? Why don't you talk about, read each statement as a table and see if you can figure out what should be filling in the blank. Like now, come on. Like now. Dayless. Go ahead. Come on. Go ahead. Go. If you really don't know what's filling in the blank, then leave it, and then we'll come back to it. I want you to try it. Doesn't hurt. If you really don't know, then you can leave it blank. I want to see what you said. All of them too. All 4 statements. Okay, get your final thoughts. By the way, it's okay if they're wrong. I just want to see where you go with guessing at these things. Lots of this and that. Okay, now the first one actually might be the one you didn't quite know how to describe. And I'm not saying you don't know what a polygon is. We're just trying to be specific. You have each segment intersects exactly 2 other segments. Anybody? Any takers? Cole? In the polygon. Not quite. Anybody have anything else? I think this was actually the trickiest one. Cece? At their endpoints. Nice job. I actually think that's the trickiest one. Each segment intersects exactly 2 other segments at their endpoint. That keeps them from overlapping. I saw a couple people, like I saw you over there, like doing this, because you can't cross. They have to intersect at their endpoints on the outside. Okay? Now, some of these other ones you might know. Actually, I'd say the 3rd and 4th ones were the easier ones. No 2 segments with a common endpoint are. Wait.
Parallel?
Parallel is not bad. That's actually not what we're looking for, though. It's not bad. It's not quite accurate. It's a word you probably never used before this year. Collinear. Now the next 2, you probably have these, okay? Each segment is called a, I bet people know this. Ronan?
Side.
It's called a side. Good. Oh, I had that on the next slide. Sorry. And then each endpoint of a side is a vertex. How many of you got the last 2? I kind of figured that would be the case. That's pretty good. Okay. Good. Okay. So you know what a polygon is. Let's not act like you don't know what a polygon is. These are all examples. These are all non-examples. Okay. It can't be curved. Okay. It's got to be closed. Can't overlap or intersect. So anything curved is out. Okay. What do we mean by these parts right here? Okay. They meet at a side, and then each is a side, and then when they meet, we call that a vertex. How do you name a polygon? You start at any vertex and list the vertices in order, either clockwise or counterclockwise. So I can either go this way or that way. There's a lot of names for this polygon. Okay, shouldn't be super difficult. How many sides does that one have? I had a feeling that might happen, okay? Let's try it again. 1 number. You can only say 1 number. None of the surrounding numbers. How many sides?
67.
Okay, good. Okay. Couple other definitions. A diagonal. You need this one. What's next? A diagonal is a segment that connects two non-consecutive vertices. Why do they have to be non-consecutive? If you connect two consecutive ones, that's just a side. So if I went back to our friend here, I can connect or make a diagonal if I start at any vertex and go to any non-adjacent. See, the adjacent ones don't count because it just makes a side and makes a side. But I could draw a diagonal to each of these. Okay, I could draw a diagonal here. Okay, but the reason that we don't talk about ones next to each other is that just makes a side. Okay, now one of our first lessons, I told you there were concave and convex. Okay, I think you have them in your notes finally. There's two kinds of polygons. Okay, there are convex and concave. By definition, convex, what does it say about all the diagonals? It has no diagonals with points outside. So if you look at this particular one, all of the diagonals, they stay inside, versus a concave, at least one diagonal goes outside. So they show two of them. This diagonal goes outside, and this goes outside. This is actually easier to tell though. Can you see how this one, it kind of caves in right here? Do you see what we're talking about? Yes? No? I see it. It caves in. That's concave. Okay, so there's convex and concave. The majority of the polygons that you're used to, guess what? Convex. If I made you draw a polygon right now, most of you would draw a convex one, where all the diagonals are inside, but there are concave ones as well. Okay, let's keep all that stuff in mind. Okay, more definitions. And again, you should actually know a lot of these things. That's why I have most of it written out for you. A circle. If I asked you to define a circle, I'm not sure how many of you would actually give me the formal definition. You would probably say like a round thing or a circle thing, or you would do this, exactly. Okay, that's the actual definition of a circle. It's the set of all points in a plane that are equidistant from a given point, and that's called the center. That's the full definition of circle. No one really says that. They're like, I know what a circle is, but that's what it is. You start from the center, and then all the points equidistant, that makes your circle. Where have you been doing this, basically, for the last couple of days? Compass. Good job. Okay. So if that's my center C, let's see how I do here. I don't really always do well with this. A circle shape. Ooh, see, look, regular polygons. Irregular. Ooh, look at that. This is actually fairly new. This one. That's a letdown. Oh, do I do this? That's a letdown. It made it look like. Doesn't make it look like the shape's just gonna like pop. Oh. Okay, that's not what we're doing. Let's see how I do here. So shapes. That's my center. Oh, pretty good. Pretty close. That's the full definition of a circle. The set of all points equidistant from the center. Things you already know. A circle is not a polygon because it's rounded, and a circle is named by its center. That would be circles. Okay? Radius and diameter, you'll notice the definitions are there for you. I'm not going to insult your intelligence. You know what the difference is. However, you know that there's definitely times where we need this, and there's times where we need this. Okay, by full definition, okay, they're defined by their endpoint. Okay? The perimeter P of a polygon is the sum of the lengths of its sides. The area A of a polygon is the number of square units it encloses, and we measure that in square units. The next page has that chart on it. You should know pretty much all of those. Can you refer to these on an exam? No. But you also should know them at this point. Let's be quite honest. Okay? And we don't call the perimeter of a circle perimeter. We should all know what we call it. Circumference. So I want you to work as a table. Find the perimeter of that triangle right there, EFG. Not the area, the perimeter.
So that Plus 10. I know. Wait, is it 6 squared?
Okay, making 24. So, you're probably wondering, how could you ever do this that quickly? Little thing called Algebra 1. So, you could just count this. This is 6. If you don't believe me, just count it yourself. And you can count this, that's 8. So I'm 2/3 of the way there. I technically need to use the distance formula for this. 6 squared plus 8 squared, 100, C is 10. If you remember from last year, I don't know if anybody does, I taught you a couple Pythagorean triples. I said 3, 4, 5 was one of them. Isn't this triangle just doubled? I did teach this to you. I know it happened. Okay, so if 3, 4, 5 is a right triangle, guess what else is? 6, 8, 10. But if you did the distance formula, it's not hard. That is 24. Okay, good. I want you to try a couple other questions now. There's 3 other ones on there. There's this circle one, then there's the multiple choice beneath it, and then there's the perimeter of Jacob's desk. I want you to work on all 3 of them. Okay? All 3 of those questions.
I voted for the first 6 group that I voted for the first 6 group that I did. And there's only 3.
Oh, shoot.
I watched it.
You go. You go. I want you to do the rest of the questions on that page, not just the circle one.
Why did it say honor roll? It said just add one plus honor roll.
Labels.
Honestly, you might as well. You might as well. Okay, well, you might as well just add this little part. I'll pay.
It's not about the money. Sometimes, like, the construction doesn't work out. It won't be supported.
Oh my god, it's so smart. 4 squared.
How do you know that it's 1 plus? Oh, I guess
Yeah, like that little.
Let's go hands up for an area of about 706.5 square inches. Hands up if you have that one. 706.5. Hands up if you also included the unit of square inches. Please don't forget. Miss James will come flying across the hall and be like, I taught this to you in 6th grade. Don't do it. Okay, good. Keep going. The deck question is takes a minute. Okay, but that's the answer to that one. Be careful on the multiple choice one. I saw some interesting answers, but you should have arrived at A. I have all the work on the board for the multiple choice one. Well, less than a minute to make your last choice for the last one. Some of you have no work, so it's going to be very hard to fix what you're doing. Let's look at the basketball one. Some of you got taken aback by it. I need you to see like what the answer is, which means we're not talking back there. Okay. I saw a number of you pick C. Like it was not just like one or two of you. A rectangular basketball court has a perimeter of 232. Listen, I mean, I could spend more time on it, but perimeter of rectangles, like you know what the perimeter of a rectangle is. Okay, the perimeter is 2 lengths and 2 widths. You plug in 232. You actually could just divide by 2 right away. I don't know if anybody did that, but that's actually a good approach. It's just substitution. This is x plus 32. Throw it in and then solve. Should not have given people problems. Okay, just be careful. If you want to make the numbers smaller, if 232 is equal to 2 lengths plus 2 widths, then what must be true right out of the gate? Half of it is equal to 1 length plus 1 width. Okay, so that's how you should have gone about that one. Okay, this one, now some of it you should know right away. So who did they tell you is congruent right away? This 4, does anybody see another 4? Where is it? Here. Are there any other congruent segments? 3 and 3. Okay, so that's actually helpful. Okay, and by the way, you didn't want area, so if you started to find area, that's not what they wanted actually. They wanted the perimeter. Okay, but I've got this piece, that piece, this piece, that piece, that piece, that piece. What was the gist of it? You needed to find the diagonal piece. Can somebody start talking to me about how do you want to find it? Okay, Elena, how do you want to find the diagonal
I
piece?
made the right triangle, but like you add, it's like make it a right triangle instead of just a normal triangle, so you can find it with the Pythagorean theorem.
Okay, so I think we can all say that you want to put, come on, man. Okay, so you want to draw like this in, maybe? Okay. Can you add it in? Okay. You wanted to find that particular right triangle. Okay? All's well and good. That's what you should do, but we have to get some measurements very, very carefully. Okay, so let's stick with you. Do you know any of these right away without doing any work?
4.
Okay. Right there. It's got to be 4. They're parallel to each other, and they made, had that right angle. If this is a right angle, this is a right angle, these are parallel, that has to be 4. Can somebody else tell me, how are you going to figure out the bottom of that? Because you need to know definitively what this is. Ryan, do you know what this is?
7.
Well, the whole side is 7, and it doesn't quite go all the way. So actually it can't be 7. Sari.
It's 6.
Ugh. First of all, most of you would have guessed that anyway, because if it wasn't 7, it would have to be that. Sari, rather than deal with anything else related to whatever those numbers mean, can you tell me how you would prove to somebody it is in fact 6 and not the other number?
On the top it's 5 and below it it's 4, so that little piece has to be 1.
Hmm.
So you subtract the 1.
Good. Yeah, I feel like you probably did problems like this for Miss James without the algebra component, but it's opposite sides. If this is 5, this is 5, but this was already designated as 4. Okay, so this has to be 1, and if this is 7, this is 1 less, and then we have it. Okay? You have to use the Pythagorean theorem on this. There's no way around it. Okay, but you have the calculator. 4 squared plus 6 squared is equal to, I don't know, w squared. Okay, you get your answer. I think it's the square root of 52. Roughly 7.5. Then you add them all up, and they made it very close for you. It is in fact 34. Okay, good. Questions about that one? That one's tricky. You need a way to prove to me what that diagonal segment is, though. I'll look at your work a little bit later. Okay. Now, there's a couple other questions that you're going to run into. There's a couple perimeter ones and a couple area ones. I want to go in a different order. Rather than give you the postulate and then go back, okay, I'm going to give you the postulate and then I'm going to let you work on these questions. So skip ahead to postulate 110. We'll fill it in. And then I'm going to let you work on the questions. Postulate 1.10, your last of chapter 1. And remember what postulates are. They're given facts. They don't need to prove them. That's going to change in chapter 2. The area of a region is the sum of the areas of its non-overlapping parts. Nancy, what does it mean? Area of this weird looking shape? How can you do it? You can find the area of this plus the area of that plus the area of that plus the area of that. You already knew that, but we have to technically designate it as a postulate, okay? So here's what you're going to do. Rather than, I want you to backtrack, rather than me like giving you some and stopping you, giving you some and stopping you. I need you to work these questions. I need you to be focused. Some of you are losing focus after like 5 seconds, and then you're like, I don't understand this. You got to focus on every question. Because in theory, I could have given you all of these area and perimeter problems with no instruction. I could say we did them last year, because we actually did. You just got to focus and give them what they want. Okay, so what questions do you have? You have the botany club question. I think there's actually 2 parts to the botany club question. And then at the bottom, you should have, I think, 3 of these where you have to find the area. Okay, I want you to do all of those questions. Show what you're doing to get your calculations. They shouldn't be a problem. Okay, but go ahead and work together on them. We'll make sure we get them all before we get out of here. Start with the botany questions.
So important to like you need a 108. 108. What is
No, the
Separating the
outside of the path. Outside of the path. No, it's just outside of the path. Whatever. Yes, it does.
It has to be inside.
No, it's the outside. It's like it literally says outside of the path. Forage, you have to add
Do not forget your labels. Labels, labels, labels. Yes, you can do these as well. Yep. All the questions on that page. Don't just do the botany ones. I want you to do all the questions on that page. It's fine. These are work. Oh, that's yours. That's yeah, that one.
So you see the 24.
I'm just saying it's the area.
I hate surgery. It's not hard, but I hate surgery. Like surgery, just like delete something.
Don't ask me, do it yourself. Yeah, because you can find an area.
Alright, so the answer for the
Don't tell me.
I've never heard that.
How do we feel about 108 or 108 feet for the first one, for the botany one?
I literally said that.
You did, I know. I saw that you did.
You're pressuring me out of it.
If you're not sure where it comes from, just look at my diagram. It's actually just a perimeter question.
Where are we supposed to do it?
At the bottom, yeah. I want you to do that whole page, yeah. So there's the first one.
And then we were, okay, so this yeah.
Anybody feel like they can give you the second botany one? Sawyer.
368 feet square.
Square feet, nice job. In general, I don't know if anybody did what I did. I did the area of the entire thing and I subtracted out the area of the garden. It's just a simple calculation. You end up with 368 square feet. Okay, please be careful on the 3 at the bottom. Okay, those are the last 3 we're gonna do. One of them needs to be estimated, the other 2 do not. Okay, that's how that one's done. Please be ready to justify your work to me on the last 3.
Oh, and you're running your just add,
I'm doing it, hold on, 4, 8.
yeah, but like if we're doing 5.
Hey, stop. Do you know how to find the area of the triangle?
Oh, no, I forgot.
The area of the
Did anybody do the first one the way I did it? You didn't have to do it that way. That was just what spoke to me.
I divided it into like.
I've seen people divide it into all these squares. That works too. It's the same thing. It's the same answer.
I didn't realize.
So we're playing.
We got 7. I don't have that one.
I don't have that.
You actually multiply the
I don't know. Oh, yeah.
I just feel like radius would be What did you get for the last one?
No, but here's what it's like.
And that one is 700.
Can I see hands up for 64 square feet for the second one? 64? I noticed the bottom rectangle was 48. These are all 4. So therefore, you can actually calculate the area of the triangle. This is like what Sari mentioned earlier. If this is 12 and this is 4, this is 8. So therefore, that little triangle is 16. Okay, take another couple minutes to work on the last one. The last one's tricky. There is a scale to it. Please don't miss the scale. They show it at the bottom.
What is the most like
Yeah, 3.14 for high is good. Too small, too big. Let's see. Did you find a scale? Did you? Yeah, so if you if you have a scale, if you are doing like length by width, if you only multiply by 4 once, it's not going to be enough. Yeah. My advice would be do each dimension. It's not how long is like on one side. Do 4 times 4 is 16. And then after the side, you multiply that by 4.
Wait, so it would be like.
You could do the final result times 16. Let me decide.
I got it.
Who did it? I'm not even asking you to write things down. That's like your critical. You gotta talk. You can talk. Yes. I'm gonna slowly start revealing the last one, but I'm gonna give you a chance. I know you know this, but your best bet is this. I know a lot of you know that, but still, you gotta be extremely careful. Yeah, I can check it. I don't think you applied the scale at all, did you? Work.
Mr. Cal?
Yeah, they're rounding, it's a little wonky. Just show everybody.
I changed that.
I think you're wrong. This is not that's too low. Okay, take a look. Did you, Moxley, did we discuss yet?
Yeah.
Yay! What did you decide? Your answer? Go ahead, tell us.
637.1.
Okay, the last one is about 637 square feet. Please watch, because a lot of you had the right idea, but there's a couple details, and the details matter. Again, I could have actually given this to you last year at the end of Algebra 1. When we were doing area problems, I could have. We did stuff like this. There's actually not a lot of new stuff today. First of all, let's watch. You have to draw this line in properly. Your paper is super duper small. You can't draw it in here. You're already in trouble. Can we all agree? Half circle plus rectangle plus triangle. Can we agree on that? Advice. If they give you a scale, you should multiply everybody right away. So this is 3, 5, and then 6. But I would multiply them now. So 6 becomes what? 5 becomes, and 3 becomes. Okay. You should do it right away. The rectangle is 12 by 20. The triangle is 24 by 20, but sliced in half. The circle's tricky. So if this is 20, that's the diameter. You want a radius of 10. And if you do these calculations, you do end up about 637.1 square feet. Again, I would encourage you to look at today's activity, all of it, and ask yourself, how much of this was new? Maybe a few definitions, but the calculations, nothing new. Okay, maybe just a little rusty. You can use a calculator on your homework. You'll get one on your next test. You'll probably need it, okay? Let me put my calculators back.